Okay, this is 8-5. We're still working on uniform motion problems. So, in this situation, Joe and Lisa are 44 miles apart, and they start biking toward each other. If Joe's traveling 6 miles per hour faster than Lisa, and they meet in 2 hours, how fast was each traveling? Do you guys want to take the time to write this problem down?
Yes.
Give me a show of hands. Okay, so write it, go. All right, so everybody wrote the problem, and now we're going to draw the situation. What is this situation going to look like? Who can tell me what the situation's going to look like? Grant.
Two arrows going together.
Okay, there are 40. Okay, so there's 2 arrows. I'm going to make one arrow a little bit longer. Okay, what are we going to call the big arrow, the longer arrow? Kelly?
Wait, never mind. It's Joe.
That's going to be Joe, yeah. Okay, we're going to call the bigger arrow Joe. And what are we going to call the little arrow? We'll call it Lisa. Now, what other information do I know about Joe? Belen? Okay, he's traveling faster, so we made him longer. Okay, anything else I can add to this diagram? Belen? So from here all the way, that's 44 miles. Is miles a distance, a speed, or a time? It's a distance. Okay, so now I can start adding each information into my table. And I'm going to call the first one Lisa and the next one Joe. Okay. So what do we know for sure? What's the easiest to fill? Carlos? Okay, is that the easiest thing to fill? Okay, where do I put that 44? Distance, which row? Bottom row. So that should be a 44. Okay. What else can we place given the information, Dixie?
The 2 hours.
Okay. Where does the 2 go? Which column? It has the name. Each column has a name. That's not the name of the third column. What does the third column represent? Time. Under time, I'm putting in the first and second box next to Lisa and Joe. 2. Okay, what else do we know? Arya. He's traveling faster. So what do we call, do we know their basic speed? But the same speed they have in common, we don't know, so we're going to call it R. Okay, but Joe is traveling 6 miles an hour faster, so how am I going to show that? Ronnie? Good. Okay, so then I multiply across and I get 2R. And here I'm going to get 2 times the quantity of R plus 6. And what will my equation be? I want to hear from somebody I haven't heard from. Okay, let's go with Alex. What's the equation going to be?
It's going to be 2R plus 2R plus 12.
Or don't do any math in your head. Plus what?
Plus 2 to the quantity of R plus
Times the quantity of R plus 6
equals 44.
Okay. Now, what would I do next? Sam? Okay, and I get? Equals 12? And now we combine our like terms. Now, what does that mean? R equals 8. Kelly?
Lisa is traveling 8 miles per hour.
Lisa is traveling 8 miles per hour. And what is the question asking? Cynthia?
How fast each of them are going?
How fast each of them are going. So have I answered that question? Okay, so what else do I need to do? Cynthia?
You need to plug in 8 into R plus
Oh, so I substitute 8 for R, and what do we get? For, it's Joe. So then, in a complete sentence, I'm going to say, Lisa travels 8 miles per hour, and Joe travels 14 miles per hour. That is your answer there. Don't just give me R equals 14. Don't just give me R equals 8 and R plus 6 equals 14. I want to know who it relates to. So it's their speed. Okay, questions? Can I erase? Okay. Moving on. Now, notice my PowerPoint. They're still calling things X. Since we're in distance equals rate times time, I use the variables R, T, and D. Because if I find a T and it's asking me for an R, I want to know. It's going to be more evident to me if I have a T or a D or an R versus an X or a Y. Do you understand that? So I want to be able to apply it as I'm working on this. This is the big bad voodoo daddy that I got so frustrated with this morning. I did it perfectly right the first period. Second period I made a mistake, and then when I went to go change it I made another mistake. So here we are. This is going to be the true test, Yamasaki. Okay. Why don't you guys write this one down? Pause the recording. Write this problem down. Okay. So we're going to draw this situation that's happening. This is a different kind of motion problem. And okay, I'm going to label my first one Karen, and the second one will be Mark. Okay? What's happening with Karen and Mark? What's happening with Karen and Mark? Cynthia?
So Karen leaves left for work.
Mm-hmm.
Got her briefcase. Mark was going to give it back to her.
Okay, so do they both start at the same or different places? Same. So Karen's going to start ahead of time. She's going a little bit further. We'll call her Karen, and we'll call this one Mark. Now, what else do we know about Karen and Mark? Dixie.
Karen is traveling at 50 miles per hour.
Okay, 50 mph. And Mark?
And Mark is traveling at 70 miles per hour.
Okay. Okay. Now, I know that the first one's Karen, the second one's Mark. What can I start labeling in my boxes? Who remembers also what kind of an equation this was that first day we talked about word problems? Urani?
The race.
It's the race, and that was going to be... Yes. A equals B, meaning one will be equivalent to the other. Okay, A equals B. Now let's see what kind of information we can get. What can we fill into our box? Nick.
For rate, we could put for Karen 50 miles per hour.
And for Mark?
70 miles per hour.
Good. Do we know the distance each traveled? Okay, what do we know about the time? What do we know about the time? Miles.
Karen has 15 minutes before Mark.
Okay. So can we say they both traveled the same amount of time, but one traveled more or less? How is Mark's time in the car compared to Karen's? How would you describe Mark's time in the car? Aria. T minus 15. Close. But we have a situation here. I'm looking at some 8th graders. Am I going to use T minus 15? You're very close. Why, Grant?
Because Karen left first, so it would be T plus 15.
It could be either, but we're doing... Mark is leaving... We're fine with the T minus 15, but there's a certain thing that I need to change here. Belen.
Well, Mark left after Karen.
But that means he has less time, minus 15 minutes. So that's accurate.
Same time.
They didn't leave at the same time. Mark left after, so he's in the car for a shorter amount of time. So whatever the time was, it's less 15 minutes.
So why is that wrong then?
Belen?
Well, Mark is traveling the last semester.
Right, but so I'm asking about the time. Josh.
Is it T minus 3/8?
What?
Because 15 minutes depending at miles per hour, so then I do like 15 over 60 and 6
Okay, 15, if you're going to... 15 minutes is how much of an hour?
It's quarter. Oh yeah.
So, what is it going to be, Josh?
T minus 1/4.
Good. So now, Mark, in relation to Karen, is the same amount of time minus 1/4 the time. Because 15 minutes is 15 out of 60. That reduces to 1/4. You could have done decimal too. It doesn't matter. Okay, so now, what is the distance?
Wait,
Yes,
didn't Mark leave after Karen?
right.
So why is it subtract 1/4?
Because it's 1/4 the time. Is he in the car as long as Karen? More or less? He's in the car less time. Okay, Carlos.
If you multiply the sides, so not for Karen it would be 50, yeah?
What?
And for Karen it would be 50 T sides.
Okay, and then,
Mark would be 70 to the quantity of T minus 1/4.
okay, times the quantity. Okay, so now what is my equation now? Yes.
Since it's A equals B, wouldn't it be 50T equals 70 times the quantity of T subtracted?
Exactly. 50T equals 70 times the quantity of T minus 1/4. Okay. Now, what would I do? Dixie?
You would distribute.
We're distributing. And so I get 50T equals 70T. And now I can cross cancel or leave it whole. I think I'll cross cancel. I can divide 2 out of here. And I'm left with a 2. And I can divide this by 2 and get 35. So it'll be minus 35 over 2. Next step. Grant.
Multiply the whole thing by 2. Oh wait, no, never mind. You subtract 70.
Okay, I think it'd be easier here. And then minus 70T. What do I get?
20T equals
What?
negative-
What?
A negative 20T equals negative 35 over 2.
Now what would I do, Grant?
Now you multiply by negative both sides by negative 2.
By 2. Okay, and then I get negative 40T equals
35.
negative 35, right? That cancels.
Negative 40.
Divide both sides by negative 40. Now, here was my clue, right? Actually, here, earlier today, I solved this, and only one side had a negative. And that's when I went, wow, Yamasaki really messed up.
How?
I found it because when I was doing this earlier, here's what I got. I got negative 40t equals 35. Why did I know I messed up here? Jake.
This time 50 negative.
Right. I'm noticing, I'm left with only one negative. And my common sense told me time cannot be negative. That's when I knew to go back and redo it. I knew I did something wrong. Okay, so here I know I'm doing something right because all of a sudden I'm seeing two negatives in the problem. And so I get t equals, I'm going to reduce it. It's 7 over 8. Negative divided by negative makes a positive. And so that is 7/8 of an hour. Time, we're in hours, is 7/8 of an hour. I will not require you to go back to minutes. But if you wanted to convert it to minutes, I'm not sure if Miss Kitchatori taught you guys about dimensional analysis. So if I'm here, 7/8 of an hour, I turn that into a fraction. The unit goes on top. I can multiply by a fancy fraction of 1. Who can give me a fraction of 1 that involves time? Time. Aiden.
60 over 60.
60 what? Equals? What does 60 minutes equal? 1 hour. Are those equivalent? So, isn't that another way if I put 60 minutes over 1 hour? Is that the same thing? Or 1 hour, it's the same number over itself, so it really only equals 1. Now, the way I figure out how to do this is I make a fraction with 60 minutes and 1 hour. And I want to cross cancel my units. So what's going to go in the denominator? Minutes or hours? Hours. So I'm going to say 1 hour is to 60 minutes. This is really just a fancy 1. Hold on. So now I can cross cancel. I multiply across. I get 420 minutes. Oops, didn't mean to do that. 420 minutes. Right? My units, I'm left. 7 times 60 is 420 minutes over 8. Divide it out. And you get, I'm left with the unit. It's 52 and 5/10 minutes. That's what we call dimensional analysis, where we multiply by a series of 1s to cross-cancel our units. This is what you use in calculus. It's also what you use in physics. Unfortunately, most of the time when it's in the standards at this point, it's been in the standards under 7th grade, and it's just a lot for the kids to handle. Grant.
Okay, so what I don't get is how 7 hours times 60 minutes can make 120 when 60 minutes would really equal 0.60 because hours is a whole another set of time than minutes.
Right, but isn't this equivalent?
Well, if you say 60 minutes, it would be the same. It should be 42.
Okay, what does this equal?
42.
What does 6 over 6 equal?
1.
Okay, can I also write this? Is this the same thing?
Yeah.
Just a different way to write it. So all I'm really doing is writing it, but I'm putting my units in the denominator so I can cross cancel them.
I'm just gonna talk.
Yeah.
When you divided 35 by 45, wouldn't you get 7/9 instead of 7/8?
No. 35. It was 35. Oops. It was 35 over 40. 5 goes into 7. 35 7 times, and 5 goes into 40
I thought it was
8 times.
I thought it was 35 over 45.
No, it was 40. Okay? All right, don't worry about the dimensional analysis right now. I'm not going to be asking you to convert that. Once you convert in the beginning, that's good enough for me. Okay. So, one more time. When I ended up with 7/8 of an hour. Are there questions there? All right, let's try the next one.
We did it.
Okay, wind and current problems. Okay, wind, when I'm in a river and I'm swimming down the river, what does the water do to me? It pushes you faster. Okay, so that means you have, or let's say a boat. The boat is moving and the boat has some speed on it, but the water also pushes it and adds some speed to it. The same thing happens when you're going up the river. When the boat is coming up the river against the current, what's happening to the speed of the boat? It slows it down. Same thing happens in wind. When an airplane's going with the wind, it goes, if it's going with the wind, it goes faster. And when it's going against the wind, it's going slower. But every time with all of these, the airplane's not just being moved by the wind, right? It has some speed on it. It has a rate that it's traveling at. So when we do our wind and current problems, now they use P and W, but I'm going to call P R. Okay, this is just going to be an R. You got that? Because I like to talk about a speed as a rate. I want you to know that what you find is going to be a rate. So, oops, I can't do this. So let's go. Our rate times time equals distance. I've got the plane that flies 1,200 miles with wind in 4 hours. And the return trip against the wind takes 5 hours. Why does it take longer against the wind? Byron? What? The wind is slowing it down. But remember, the airplane still has a speed. So let's try and fill this, okay? This is with wind and against wind. Well, you know what? I'm going to write it over here so I have room for a diagram. Okay. What's happening in this diagram? I'm traveling to Hawaii, and then I'm traveling back. This is 4 hours. This is 5 hours. This is wind. This is against. Okay. Now, what can I fill into my box? Evan,
How fast the
loud so I can hear you.
how fast the plane flies.
Okay, so we know the speed, huh?
Yeah, it's 1200.
Huh?
1200.
That's not the speed. What does it say? 1200 implies... Aria? Distance, because it's just miles. If it were the speed, it would say 1200 miles per hour. It has both time and distance in their unit. So where do I put that 1200? Burke.
In the third box in the distance.
Okay. And we're going to put that down for with wind or against? Going to Hawaii and coming back.
With.
Okay, so it's only the distance for with wind. I'm going to Hawaii and I'm coming back. Are the distances the same or different? Same, so I've got to put it for both. Do you understand that? I drive to school, I come home. Same distance. Okay, do we know the rate? Do we know the time? Aria, what's the time?
The time is with the wind is 4 hours. And against the wind is 4 hours.
Do we know the speed of the plane? So we're going to call that R in both cases. Only in the top one, the speed is getting what? Pushed by the wind. So how would I show that? Grant.
By adding
What do you think? You got it.
adding W.
Yeah, adding W. But when it's coming back, it's going against the wind. And so how am I going to show that? Yes, go. Yep. Now, if they tell you in your word problems tonight, a speed, the wind is 6 miles per hour, that's going to be R plus 6 and R minus 6. Does that make sense? I don't know the speed of the plane, but I know the speed of the wind. Or if they tell you the speed of the current in the water. So my two equations are 1200 equals 4 times the quantity of R plus W, and 1200 equals 5 times R minus W. Can I erase?
Yes.
Okay. All right, so I'm jumping ahead over here. I could do two different things. I could distribute, and then both equations would be in standard form. And, but I can do something a little bit easier. What happens if I get rid of that 4? What's the inverse operation of 4 times? Urani?
Divide all times by 4.
Yep. And then I'm left with P plus W equals 300. And if I divide the other one, both sides by 5, now I can do the elimination addition method. Line them up. What am I left with? What can I eliminate? Cynthia. And then I'm left with equals
5.
divide by 2. And what does that mean? P, actually, let's go back. I called this R. I called this R. I called this R, 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 R. Okay. So what does that mean, 270? Shh. What does that mean, 270? R is 270. Brent. Right, the speed of the plane in still air is 270. The speed of the plane in still air is 270. Okay? If I go back, okay, the speed of the plane in still air. But what if I wanted to find the wind? What if I want to find the wind? Okay, what am I going to do? Let's go with Kelly.
You could multiply the bottom, the second equation with
Do I need to multiply? Can I just use this equation here? Or this equation here, because it should be equivalent. So if I substitute it in for R, or P, 270 minus W equals 240. Then I'm subtracting 270. No. Yeah, subtracting 270. I'm left with negative W equals negative 30. So W equals 30. What does that mean? Carlos? Yeah, the wind is 30. Okay, questions? Did the P mess you guys up?
Yeah.
Who said yeah? Okay, so P they're calling our R. They're calling the rate P, as in plane, instead of rate. But it means the same things. And so when I get my R was 270, that's the speed of the airplane, with or without wind. Does that make sense? All right, I don't think we're going to have time for another problem, so that's the end of the lesson.